Okay, so wrap your right hand around the solenoid so your fingers point in the direction of conventional current around the coil. Your thumb points to the North Pole end of the solenoid. This could help you. So for example, if you're going in, that is south, and you're going out is north. So remember, you're coiling your hand. The thumb will point to the north. So here, if you look at this diagram, this is conventional current. So conventional current is from positive to negative. So if you're going in, it is south, and going out is north. This is the difference in electric potential. Now remember, potential is the same as voltage, and voltage is energy per charge. So remember that force times distance is energy. So if you use Coulomb's law, you're multiplying that by distance, and then you're dividing it by charge. So you end up with kq over r. And when you're doing the difference between two different voltages, you do kq brackets 1 over rf minus 1 over ri, close brackets. This is the difference in electric potential. If you have three individual charges and you have a test charge in the middle, let's just say, to work out the potential, you add up all the three individual potentials. So you got kq1 over r1 plus kq2 over r2 plus kq3 over r3. This is just a symbol for going into the page and out of the page. X means going into the page, a dot means going out of the page. This is the equation for capacitance. So C is for capacitance, and that is directly proportional to the cross-sectional area of the plate, and it is inversely proportional to the separation of the plates. So the electrons flow into the negative plate, and remember that the plate on that side builds up electrons. As that builds up electrons, that builds up charge of negative, and that repels the electrons on the other side. That leaves the positive plate. If the plates are large, the accumulated charges are able to distribute themselves over the area. The amount of charge that can be stored on a plate for a given PD increases as plate area increases. The capacitance is proportional to the plate area. The plate separation D, if the battery is constant, has constant PD between its terminals, the electric field increases as you make the distance shorter. So the capacitance is inversely proportional to D, because the closer the plate separation, the charge on the capacitor increases. This is due to the electric field. Permittivity is the measure of how easy it is to generate an electric field in a given material. So this is just going back to the solenoid. The difference here is just the magnetic flux density. The magnetic flux density on the left-hand side is more than on the right. If you just look at this animation here, remember that you're coiling your hand. This using the right hand grip rule. The thumb is pointing north. So in this case, going in is south and going out is north.